Okay, so I want to talk about Yang 1.1 and NMDA because that's the sort of news in the Yang modeling business. So how many of you, we didn't get to stand up here, so how many of you are actually making Yang models, writing Yang models? Stand up, please. How many of you are modeling? Yeah, more than half anyway. Good, thanks. You at least, you're the ones that need to listen now, so that's good that you have some blood in your system. This Yang 1.1 has been out for a while, and actually we could have talked about the Yang 1.1 implementation in NSO even last year on this developer days, but there was no room for that, so we didn't. But now I still see quite a few people modeling in Yang 1.0, and there's really no reason why you want to model in 1.0 anymore. There's no particular drawbacks with 1.0. There's no particular drawbacks with 1.1, so you can go and move over. So you get some more power, and that's what I want to explain to you now, what you get if you move over to 1.1. And also a lot of talk about NMDA these days if you have been following. So I wanted to give you a few highlights. What is that and what does it mean? Okay, and the Yang version 1.1 and 1.0, that has nothing to do with netconf 1.1 and 1.0, which also exists. You can use any combination of those. And you can also use Yang with other things than netconf completely. Okay. So first, there's a few corrections in Yang 1.1. And it is, if you have strings in double quotes and use this backslash something, Yang 1.0 says that backslash n means new line, backslash t means tab, backslash quote means double quote, and backslash backslash means backslash. But it didn't say what, if you say backslash something else, what is that? But in Yang 1.1, it specifically says that is illegal. It does not mean anything. So now if you compile, the compilers are much more chatty and giving warnings about all sorts of things. What do you really mean when you have backslash d or backslash star or whatever it is? And if you want to have strings that are not doing anything special with backslash, use single quotes. So that's what the general thing. If you get warnings about having these strange things, change your quotes to single quotes and this should be fine. It's also, another clarification is that if you have if feature or when statements on things that are keys, Yang 1.0 didn't exactly say anything about that, so the exact meaning of that is sort of unclear. Whereas Yang 1.1 says that is not allowed. I think many implementations would either do something that you don't want or crash or something if you try to do that with 1.0. Okay, so then there's some changes. The most important change for Yang 1.1 is, of course, that you have to declare your module to be Yang 1.1. You do that by just after the module name, open brace, you say Yang-version 1.1 semicolon. And now it is a Yang 1.1 module. That was easy. You will also notice that if you have Yang 1.1 modules, they will not be listed in hello. There's another mechanism called ietf-yang-library. I'll talk about that on the next slide. And also, the way that includes works has also changed, so I'll talk about that too. Here's ietf-yang-library. If you look here on the left, I did a sublime look at exchange between NSO and an XR system. Here's the hello message until here. Here's the actual request, and here's the response. So we are sort of, because in Yang 1.0 you have to list all the Yang modules that you support, all the namespaces, and it's starting to get fairly long. So it's a kind of long-winded discussion about hello, hello, how are you, what's the weather, and then you actually have your request. It's just like social life nowadays. So in Yang 1.1 modules, they are not listed in here anymore. So if you move over a lot of your modules to Yang 1.1, the hello message will get shorter. So that's good for efficiency. And instead, there's something called module set ID, which says that, okay, here's some sort of string or number or something representing the set of Yang modules I have. The next time I change which modules I have, I will change this number. So if you just connect and see that this number is the same, well, it's the same as always. And if you want to know exactly what it was, what do you want to talk about with this guy, you go to the ietf-yang-library, where you can get a name revision, you can actually get the URL to the schema, which features and deviation it has, and all other things. So you can look all that social stuff if you want to, when you want to, whenever you don't either know what this module set ID means or if it's changed. And there's also a notification in here so that you can subscribe to tell me, hey, if you change your schema in some way, you may get some more modules because somebody added a new feature, or a new license for something, and you have some more capabilities. please do let me know. And the other thing about include is that in Yang 1.0, there was a total mess with includes. I always, in my Yang classes, I always told people, don't use it. There's no point, I don't even want to explain how it works, but in short, in Yang 1.0, you had to include everything that you wanted to refer to. So for example, you had a lot of, one submodule with some common types that everybody should use. You had to put that in a separate module, because these guys could not see the definitions that were in here. So you had to put that in a separate module, and then these guys, they have to refer to all the things that are in all that they have to include. But it's not allowed to have circled references, so you have to be very careful about what you put in which module. It's a mess. Don't use it with 1.0. In 1.1, this guy includes the stuff, and you're done. So it's actually usable here. I don't want to recommend people to go start using include and submodules very much. I don't find that concept super useful. But if you do, you can do that in 1.1. Now it works. Then we have some additions. I'll go on a list here, just to give you some highlights why you would want to use Yang 1.1. Okay, so you can put actions and notifications not only on the top level of the module now, but inside some other object, maybe on the interfaces or whatever you have, somewhere deep down in the structure where it makes sense. When you do that for actions, it's similar to the tail-f action. Actually, we suggested this for the 1.1. There is something called modifiers for patterns. So if you have a string that it needs to match this pattern, you can also say that, okay, but it must not be something, by saying it must, any string, but not default and not none, because this is invert match for this one here. This makes some of these pattern statements hugely less complicated. And there's something we call the weak references. You can have leaf refs that point to something that may not exist. So you require instance false. One of the things that OpenConfig does a lot is they use this, but in Yang 1.0 modules, which doesn't make sense really. Another thing that's new in Yang 1.1 is actually relaxations, because must exist already in Yang 1.0, but you can now use must in RPCs, actions, and notifications. So you can have must constraints describing the data. I mean, in a notification, the must is still relevant because it gives you information about the data that you will receive back. It gives you guarantees. Well, when you get this data, it's either that, or it has this one is always larger than that, or whatever it is that you describe in your must statement. In Yang 1.0, when you augment things, basically one module adds stuff to another module. Those things that it is adding must never be mandatory. Why not? A lot of people want to add mandatory things. Yeah, this makes it has to be mandatory. But the problem with that is that whoever implements this first module, the original module, without knowing anything about your addition, they will break if you add mandatory stuff to the model. So you're not being backwards compatible if you're adding mandatory stuff. Now, this is somewhat lifted in Yang 1.1, because now augment allows you to use mandatory and must statements that are making things that they have to be there, but you need to use your brain to make sure that these are not breaking anyone that is using an old client. So this condition must depend on something that is new in your own model, or mandatory in the context with a when statement when this new thing is enabled, or something like that. But the compilers have a hard time checking this now. So now this is some freedom given to you under responsibility. You are now the one to check that your mandatory statements and must statements, when statements are valid in the new context. The compiler will not be able to do a perfect job at finding out when this is legal and not legal. Some debate in IETF, I'm sure. A new thing that you can do is a leaf list. They used to not have a default statement, but now you can actually have a leaf list with the defaults and list some elements in there if you want to. It's maybe not the most common thing to do, but you can. Some other additions is that if you're using if feature, it used to be that you just name the feature here. If feature has disk, or if feature this BGP or whatever it is. But now, if you have a combination, it's either if you have disk or you have BGP, then something happens. You can have and or expressions based on this or not and stuff like that. And you can also add if feature on bits, enums, identities, and stuff like that, which was not possible earlier. A kind of interesting thing is identities based on multiple bases. I don't know, how many of you, raise your hand, how many understand what identities are? Not a whole lot. I have a slide on it in the next time, I'll show you. And there are also a lot of new XPath functions, array match, deref, derived from herself, enum value, bits is set. Those are all new XPath functions that you can use in your must and when statements. Yes? Yeah, you like it, that's good. Which one? Which one? All of them, okay, great. And also there's some clarifications, for example, that which root node, which current node are you in when you put an XPath expression, a must statement, for example, in a notification or in an RPC or something like that. So that was unclear earlier, but now it has been clarified. And also another thing that's been causing a lot of headache is when you are using identity refs, referencing identities in Yang 1.0, it wasn't exactly clear how those were represented as strings specifically. But there was a lot of Yang modules that were testing if something equals this string, but that wasn't interoperable because some implementations had it with the namespace, some without, and some in certain cases. So now it has been specified. The string representation of identity refs are always with the namespace qualification. I'll show you this now. So here's how identities work. It's a way to it's sort of like enumerations. You can enumerate all the things that you might have, all the kinds of something. But here you can have relationships between these things too. You can, for example, say like, okay, there's something called a book in a very general sense. And a book can be presented in paper, as an audio CD, or as a file. The paper, in turn, can be paperback or hardcover. And the file can be MP3, PDF, EPUB, and so on. So that you build a hierarchy out of these identities. So it's an enumeration that can both grow in the future because another module might add, oh, I have EPUB version 2 and version 3 that are based on EPUB. Because it's coming in a new Yang module, somebody else that's later. So it's much more flexible than enumerations. And you can also build these hierarchies here. So for example, you can say, okay, I have number in stock is only relevant when you have not derived from yourself, the type of this book is NS file. So I mean, you don't count how many you have in stock when you're delivering files. But for paper and audio CDs, you need to do that. So this number is relevant for those books that are of type not file-based. And that, I mean, that this expression takes away those that are marked file or MP3 or PDF or EPUB or anything that in the future comes derived, I mean, the version 1 and 2 and so on. Anything like that. And another one, similar one, we have the container dimensions, which is only relevant when the type is derived from on paper. There's only the size of the book only matters for this guy.
Maybe in that case, explain on type, how type is defined. So what is type?
Yeah. Maybe a good point. There was no space on the slide for that, but okay, sure. Type is an identity ref. And an identity that is pointing base book. So that means anything that is a book or derived from book is a valid value from that. Which means with this particular module, you have this 1, 2, 3, 4, 5, 6, 7, 8, and 10 or so identities. But if you load up a few more Yang modules that are hanging off of these, there will be more values that are possible values for this one. An identity ref anyway. And now, as we mentioned on the previous slide, the string representation of these identities are now always namespace qualified. So it should be something colon something always. We have many Yang 1.0 modules that are using sometimes like this or sometimes without, just like this, because we are NS is the current namespace for this module. You know, it didn't work very well in a interoperable manner. Okay, so the new thing with identities, I mean, this is already available in Yang 1.0. Not that these functions down here, but identities per se are. But there's a new thing here. You can have multiple bases. So you can say that, oh, you have identity book and audio book, and then you can say the audio CD is based on both book and audio book. And then you can say things like, oh, is it Kindle compatible? Well, if it is, this is a question that's relevant to ask if it is derived from a file and it's not, has anything that's derived from audiobook. Then you can have true or false. So for PDFs, they may or may not be, EPUBs may or may not be, but the question is not even relevant for hardcovers or MP3s. Make sense? I have about 5 minutes more for NMDA. Okay, I started to give some sort of NMDA background story. So, I mean, IETF developed netconf, right? That's where we started. And then we came around with Yang. And then now we're working with standardizing Yang models. And there was some trouble starting with this. I mean, after a few years of modeling, we realized there's a trouble. And this was highlighted by Open Config Consortium, which picked up Yang, but they came up with a solution to this problem that I'm not particularly happy with, and IETF wasn't either. So they decided, let's solve this, and this has led up to this, what's called NMDA today. You know, managers from the north, they need configuration. They also need operational status. And these Yang models that we made early on, they provided both of those. There was a config in there was operational status in there, and everybody was happy. Now we could finally manage in a structured Yang model-based way. But there's one more thing that we need in the manager. We need to have the relation between these two guys. The config for what and the status of what. How do they map together? And that was not perfect in the first versions of the Yang models that came out of IETF. And yeah, so NMDA is a way to marry them and also to reduce duplication. So this is what it looks like. Here on the left, here's the IETF interface model original version. Then you have interfaces in the configuration section with name, description, type. And then you have interfaces state, which is only operational. And then you have the interface name, type. I saw them earlier. This is sort of duplication here. Name and state, name and type were already up here. But they are one more time here, and then some other leaves in here. And that's maybe nice. I mean, you can have the config here and the state there. Then it's easy to ask for this and ask for that. But how do I see the relation between it? Yeah, they have the same name here. But there's nothing from a machine point of view that ties together this list with that list, and that these names should be identical to that. I, as an engineer, I understand that quite. I read quickly, interface, I get it. But NSO does not. There's nothing from a machine perspective that ties them together. So the new version of the IETF interfaces looks like this. Interface, name, description, type, once only. So it's a little bit shorter. And all those other leaves in here. That wasn't too hard to come up with, was it? Why didn't we model it like this from the start? It's kind of obvious, isn't it? Well, there is one problem there. It is that if you look at those lists, the config list and the opera list, they have different members, different instances in there. So if you look at the configuration point of view, there is gigabit Ethernet 011 and 022 in there. But you show the status, you will see gigabit Ethernet 022 and loopback. Because this card is not inserted yet, so it's not operational. And this has never been configured, it's just always there. So how could you have a list with different members? So that's when the IETF said, okay, let's have two separate lists for this. But that wasn't a good answer. So NMDA is trying to change this around so you can have the merge one and still have this separation of these things. So, you know, in netconf, you have the get config, the get, and the edit config operations. You can apply get config to running or candidate. You can apply get to running or candidate, and edit config to running and candidate. So you have these basic operations, but they have two different data stores that they can apply to, running and candidate, really. Where get is sometimes also getting from the operational, depending on which leave it is and where you ask for it and stuff. So now with NMDA instead, you are getting only get data and edit data, just two operations. And then as input to these two operations, you specify which data store are you reading. Are you reading the config store? Or are you reading the opera store? So you can, then you don't, from a model point of view, it's the same thing. You just have different glasses on you to see, am I looking for this perspective or that perspective? You can get either way, but you don't need to have the model twice over. That makes sense? Oh, now you have to say. Come on.
No. I just thought like get config and get is required, but edit config is not required because there is no operational data change we can do, right? So I was confused.
All right, it doesn't matter.
Yeah, I'm a complete newbie in network technologies, but I'm a software developer, and to me this looks somewhat wrong because to me it would be more natural to have interface/interface slash some identifier may be named slash state, and then list states. But here we have completely different instruction, different path to interface state and to interface itself. Why is it so, maybe?
That was the old way. So if you look at how it is in the new model, it's the same path. So here, everything is under interface name, and it's all here. Both config and oper. You can just see if it's read-write or read-only here. So it's one path, simple. So that's, I mean, this is supposed to be the obvious first attempt that they did in IETF when they first Model 2. This is where they started. Then they realized, oh, there was this little problem with this different content in these lists. Oh, we have to split them. But now we are trying to come to a different conclusion. Okay, let's invent some more data stores with different glasses or different angles that you look at this. And while they're at it, looking at data stores, they went all overboard. So now there's a whole bunch of data stores. You have the candidate and running and startup that we had before, but there's also now something called intended and operational. And plus, you can add as many more as you want. And a few of them are default, dynamic, system, learned, and you can add more. So you can ask for the same model data, but from all these different perspectives now. But of course, these you only have to support running and operational now. All the others are optional. But for systems that are a little bit more complicated, you can have all these data stores. These green ones here up on top, they are the normal config kind of data stores. They are read-write. And you can go between these, just as you are used to. This is much like netconf always was, right? Or the netconf model, even this Yang here. The difference when you're coming from running to intended is that here you can have transformations like inactive. You can comment out things here. They're still left in running, but it's not being used in intended. If you inactivate something up here, it stays here, but it's not being used. It's like commented out. So it's in here, but it's not in there. You can use templates. You can have templates that says, yeah, I have interfaces, they all follow this pattern. So you define this pattern up here, and then that is rolled out in here, expanded. Or you can have things that are in transition, where this is something that is currently, I mean, this is where we are heading, but this one is some intermediate step towards whatever. It has to be enabled in stages or something like that. I don't know. So then you can see those stages moving through here. So that's the difference between running and intended. And this is optional again. So if you think that this is not important for your system, well, don't have it. But if it is important for the management of your system, you can have intended as a sort of standard. It has a defined meaning. And then going from intended to operational, well, one of the things that happens here is that you also bring in all this config false data here. So that's, of course, much bigger schema. The Yang models are much more elements in the Yang model that apply. That's why I draw it larger. And the operational is then also showing not the running set of interfaces, but the actually up, I mean, not the ones that are defined in running and neither intended, but the ones that are actually up now. So the difference from here to here when it comes to configuration things is like there may be default config, you know, that loopback 0 interface that just is there, or dynamic config or learned configs. It's not so easy to define what they are, but it's other subsystems that are injecting data in here. You have the routing team in IETF that is defining the routing subsystem with a new routes are being injected from other places. It's kind of half between. It's not something that you configure up here, but it sort of has a configuration behavior. So it's being injected as a part of the configuration, but from another data source than running. And yeah, but I mean, if you look at all the old routing protocols, at one point they were all statically configured. Then we have more and more automation. So BGP is just a superhuman thing that's injecting static routes, right? So you can build those kind of things that are injecting other config aspects to the system using these other mechanisms here. So that's sort of the high-level view of what NMDA is all about. I think we have time for 2 questions. Anyone?
So what's the plan for NSO?
We are implementing this, of course, but it's. I think we'll have to be implemented everywhere. But as devices start to implement this, we will have to support the southbound, and we will also do it northbound. But the NMDA is something that's also in the works at IETF right now. It's not finished as an RFC at this point. One more.
Again, about data structure, you've previously showed model structure when submodels can reference supermodels. But isn't it a circular reference? It's generally a not very good practice. And why do some models need to know about their parent?
This is just it's I can tell that you haven't been using Yang all that long, because it's just those modules build up a single namespace. They are one unit. It's just the technicality that you split them up into separate files. So it's like include hash include in C or something like that. You're basically just taking that. They cannot be reused in any other place. No. They are just part of that particular module. So it's if the files are getting too large, or maybe you want to revision control them separately, or this is team A and this is team B or something, you can split them up, but it's not an important concept really. Okay, thank you very much.